Okay, in this lesson we are going to be talking about factoring the sum or difference of perfect cubes. So again, I want you to notice this can be sum or difference, meaning add or subtract. And perfect cubes are numbers that that you get from multiplying a number by itself 3 times. So 2 times 2 times 2 is 8, and therefore 8 is a perfect cube, excuse me. So you might want to make a list of those and have it handy if you aren't fully aware of those. Or you can use your perfect cube button under Math on your TI-84 calculator. You should find a cube button and you can type in and see if something is a perfect cube. That can help you out. So let's talk about a few of these problems. Okay, so for this first one, I have y cubed and 27. 27 is actually a perfect cube. The cube root of 27 is 3 because 3 times 3 times 3 is 27. And when you're looking at the variables, you want the exponent to be divisible by 3 to see if that is going to work for you. These, you have to remember this little rule. You always have a little parenthesis and a big parenthesis. And you start with the little one and you look at just these two things. You take the cube root of these two things. And so the cube root of y to the third, you can divide the exponent by 3. You get an exponent of 1. So you get y to the 1. And then the cube root of 27 is 3, as I said, because 3 times 3 times 3 is 27. You get these two things. And then you go to the next space. And think of 3 spaces in the big parenthesis. You get the first space from taking the first thing you wrote and squaring it. So we wrote a y, you square it, so this will be y squared. The second thing you get from multiplying these two together, so 3 times y is 3y. And then the last thing you get, the last space you get from squaring this last thing, and 3 squared is 9. So again, this is square the first, multiply the two together, square the last. The signs, there's a little pattern to them, and some people teach SOAP, same, opposite, always positive. The first one is the same as the problem, the second is the opposite of the problem, and the last one is always positive. So that might be a way to remember those. There's also a little rhyme that I have available on my website that you can pull up where I have each line labeled with a rhyme, and it goes little one, little bit bigger one, talking about the parentheses. So little one, little bit bigger one. First thing, second thing, first thing squared, product of the two, and the last thing squared. This is like that one, this is the opposite, and the last one is always positive. And so if you're a rhyme kind of person, you can go to my website and get that sheet. So let's move to the next problem. Make a little parenthesis and a big parenthesis. Again, 64 is a perfect square. X cubed, the power is divisible by 3, so we're good. And we start with the 64. You take the cube root of that. Cube root of that is 4. And then you take the cube root of x cubed, or divide the power by 3, so you get an x. So we have these two things now. I start with the one on the left, the 4 squared is 16. Multiply the two together, I get 4x, and square the last, you get x squared. Same as the problem, so a minus, opposite of the problem, so a plus, and always positive. If you want to pause now and see if you can remember it, that would be a great time because 3 is an easy one. X cubed is the power is divisible by 3. 8 is a perfect cube because 2 times 2 times 2 is 8. So we're going to start with a little parenthesis and a big parenthesis. And so the cube root of x cubed would be x. The cube root of 8 is 2. And then square the first, multiply the two together, square the last. Use the same sign as the problem, the opposite sign, and always positive. Now, before we go on, you might want to think about this. This second piece is always going to be a trinomial, and we've talked about factoring trinomials, or we will talk about factoring trinomials. This will not factor anymore. So once you've done the perfect cube, don't expect this trinomial to go any further, although sometimes you can do something with the first parentheses. So just keep that in mind. Alright, moving to number 4. This one has a plus. 1 is a perfect cube. It's also a perfect square. It's perfect with pretty much every power. 8 is a perfect cube, as we just used, and 6 is divisible by 3. So I'll show you how that works. Little parenthesis, big parenthesis. Cube root of 1 is 1. The cube root of 8x to the 6th would be 2x squared. And you're asking, how did I get the square? Again, taking the cube root is dividing the power by 3. So 6 divided by 3 is 2. That's how I get the power for that x. Come to the big parenthesis, square the first. 1 squared is 1. Multiply the two things together. 1 times 2x squared is 2x squared. And square the last. 2 squared is 4. X squared squared. You multiply the exponents, so you get x to the 4th. Then we use the same as the problem, opposite, and always positive. Okay, for our last example, you're looking at it saying, oh, well, 9 is divisible by 3. That's great, but 2 and 16 are not perfect squares, or, are not perfect cubes. Well, that should trigger the memory that we are always supposed to check for a GCF, and 2 and 16 do have 2 in common. So you want to take that out, and that's going to leave you with x to the 9th minus 8. And now you do have perfect cubes, and you will just bring that 2 along in front of what you're doing. So I'm going to put the 2, then I'm going to do my little parenthesis and my big parenthesis, and I'm going to use the x to the 9th minus 8 to fill those out. So the cube root of x to the 9th, divide the power by 3, I get x cubed. And then the cube root of 8 is 2. Then to my big parenthesis, I'm going to square the first, and so x cubed squared, you multiply 3 times 2, so you get x to the 6th. Then you multiply these two pieces from the original parenthesis. 2 times x cubed is 2x cubed. And then you square the last. 2 squared is 4. So use the same problem, sign as the problem, opposite sign of the problem, and always a plus.